Hello, my name is Patricia Rose De Leon, and today I will be doing the 7 reading aloud assignment for the class Introduction to Human Physiology. So, I believe for this video today I will be talking about endocrine interactions, and um, for this video I'll also be just doing a think aloud, which means I'll be just showing my thought process, and I won't include my annotation process. So, because it has been instructed by Professor Lee to only do the endocrine interactions part of this PDF, I won't be going over the other pages, but I'll just be talking about pages 40 to 41, which covers the topic endocrine interactions, which includes permissive effects, additive effects, synergism, muscle contractions, antagonistic effects, and I might as well also go over the general kinds of hormonal effects. So, endocrine interactions, hormones and other chemical regulators interact in various ways to achieve physiological control. So, permissive effects. Several hormones that do not have direct effects themselves in certain physiological functions are nevertheless required for other chemical regulators to affect those functions. Many such permissive effects involve the TH. For example, although TH have little or no effect on body growth by themselves, they are required for other hormones such as GH to be effectively uh, growth promoting. In addition, epinephrine has very little effect on lipolysis, or the breakdown of triacylglycerols to yield fatty release by fat cells, unless the cells are also under the influence of TH. However, the TH themselves have no effect. Thus, the TH permit the other hormones to be effective. This permissive effect frequently involves the upregulation of the receptors for the other hormones such as GH or catecholamines. So, okay, so basically what it's trying to say is that permissive effects is this, basically the kind of situation in which like a hormone, it can like, it can't exert its full effects without the presence of another hormone. And for that example, we have the TH. So yeah, basically TH or the thyroid hormone is a permissive. It exerts a permissive effect upon like the anabolic and the metabolic effects of GH. So and it increases the pituitary synthesis of the protein hormone. So basically, what it does is what is mentioned here in the text is that the G8 depresses the secretion of the tyrotrophin and the thyroid hormones, and it increases the peripheral conversion of the thyroxine and the thyroid. So yeah, in other words, thyroid hormones, they're like permissive because they exert this profound effect on like the ability of the cells to respond to other hormones such as catecholamines. Okay, so moving on is additive effects. These effects refers to the circumstances where two or more hormones independently influence the same process in the same direction, increase or decrease. When the hormones act together, their combined effect is simply the sum of two acting independently. For example, hormones A and B both increase a response by 5 units. When A and B act together, the response is increased by 10 units, which is shown in figure 4. So basically, additive effects is basically this action that occurs when the combined effect of two or more chemicals is equal to like the sum of the effect of each agents given alone, and basically interact in like a they don't interact in like a direct way. So like for example, 2 plus 2 is equals to 4, and this effect is like the most common when two like chemicals are given together. So yeah, as shown here in the graph, we can see here that hormones A and B both increase um, by 5 units, but when A and B act together, the response is increased by 10. So yeah, 5 plus 5, we all know that's 10. Okay, so synergism. This kind of interaction involves increasing the response of a system to two or more regulators in such a way that the net effects is greater than the sum of the factors operating independently. For example, hormones A and B each increase by the response of a system by 5 units. However, when they act together, the response is increased by 20 units. So, the permissive action and the synergetic effects of hormones are also called referred to as augmentation. So basically, synergism occurs when two or more hormones they combine together to produce effects that are greater than the sum of their individual effects. For example, if I remember correctly from my other endocrine studies as well as my biological studies, the testosterone and the follicle. Basically, they stimulate hormones that are required for the normal sperm production. So, as we can see here, what I mean by producing effects that are greater than the sum of their individual effects is that, as we can see here, A and B increase together by 5 units, but when they meet together, when they act together, it is increased by 20 units. Also, the permissive action and the synergistic effects of hormones are also referred to as augmentation. So basically, augmentation is like these four components that increases the probability of like releasing um, synaptic vesicles during and after like the repetitive stimulation, such that like all other components of enhancement and depression are zero, or is augmentation at time. So yeah, as we basically it's in the name. It's basically saying that um um as mentioned here, it's basically this permissive action and this combination of permissive action and synergetic effects. So last one is antagonistic effects. So in several cases, one or more hormones can reduce or block the effects of other hormones. For example, insulin functions to increase glucose uptake by cells and thus to reduce the plasma concentration of that sugar. Several hormones inhibit the effects of insulin on the cellular uptake of glucose. For example, GH, placental lactogen, and others function in different ways to elevate plasma glucose, or glucagon, or catecholamines, such as those. So basically, antagonistic effect. Basically, it's this biological response to exposure of multiple substances that is like less than would be expected if like the known effects of the individual substances were um, together. So, for example, the effect between the opposing actions of insulin and the glucagon of sugar level, as mentioned here. So, basically, what happens is when if the insulin lowers blood sugar, that means glucagon rises. And as we read before in our previous um, um, endocrine studies, that basically what happens after that is that um, it regulates the major physiological function of these two chemicals, which is very important to keep up like the healthy level of glucose in blood. Okay, so now actually I checked on the assignment instructions, and I don't need to go over the general kinds of hormonal effects, so I won't be going over trophic, permeability of cell, transport functions, metabolic effects, and so on. So I believe I will end my Think Aloud video on just endocrine interactions. But before I actually do end the video, because I did show some of the information that I've learned from this text, I might also want to tell the questions that did pop up while I read the um, the text as I went along. Okay, so for permissive effects, what is the difference between permissiveness and potentation? So I was wondering if there is this kind of difference between potentation and permissive for like drug to drug interactions. So according to FA, the permissive means, as mentioned here, is like basically the presence of substance A that is required for like the full effects of substance B. And potentation basically means that drug B, or like with no therapeutic action, it kind of enhances the therapeutic action of drug A. So I don't know, like they kind of sound like the same thing, and essentially I'm kind of confused as to what the difference is between them. So my question for additive effects is, so what is kind of like the difference between additive effects and synergetic effects? So when, like for example, like when two drugs kind of they react together, how would we know if they're additive or they're synergetic? So next up, my question is for synergism. So basically in a more pharmaceutical sense, like is there kind of this relationship between synergistic action of drugs and their like dose reduction? So yeah, like as we mentioned earlier, let's say like there's two drugs, A and B. So A has like a dose of X and B has a dose of Y, which kind of gives this individual therapeutic activity. But let's say like they are combined to produce synergism to treat like a particular disease. So my question is like during this formulation of like a combinational drug, which is A and B, um, should you reduce the dose of each drug to attain synergism, or like combine formulate like a combination with the same X and Y concentration without any of like dose reduction? So yeah. So my last question is for antagonistic effects. So actually, what's the difference between an agonist and antagonist? I think I kind of mix this up all the time, but as I kind of understood it, it's basically um a receptor agonist, like let's say for a drug will bind to the same receptor as the drug and they elicit the same response. But I think the antagonistic effects, if I'm not sure if I'm correct, but it will bind to like the same receptor as the drug, but it will block the effects of the drug by binding the receptor and like inhibiting the drug from binding. So I'm not sure if what I just said was correct, and like do these terms actually also apply to enzymes or kinetics also? So yeah. So those are all my questions for this topic. I think I will stop this video right here because all I needed to talk about for this assignment was just endocrine interactions. But I hope you enjoyed listening to my thought processes, and to access the PDF, the non-annotated PDF of this text. You can find it at the description down below. But if you also have any questions, you can put it in the comments. But otherwise, thank you so much for listening and have a nice day.